This is USMLE QA. USMLE material presented in a question and answer format structured similar to the first aid for the USMLE Step 1 book.
Question: what is the enzyme that catalyzes the rate-determining step of the urea cycle? Answer: the enzyme that catalyzes the rate-determining step of the urea cycle is carbamoyl phosphate synthetase I. Question: what is the positive regulator of carbamoyl phosphate synthetase I? Answer: the positive regulator of carbamoyl phosphate synthetase I is N-acetylglutamate. Question: what is the enzyme that catalyzes the rate-determining step of fatty acid synthesis? Answer: the enzyme that catalyzes the rate-determining step of fatty acid synthesis is Acetyl-CoA carboxylase. Question: what are the positive regulators of Acetyl-CoA carboxylase? Answer: the positive regulators of Acetyl-CoA carboxylase are insulin and citrate. Question: what are the negative regulators of Acetyl-CoA carboxylase? Answer: the negative regulators of Acetyl-CoA carboxylase are glucagon and palmitoyl-CoA. Question: what is the enzyme that catalyzes the rate-determining step of fatty acid oxidation? Answer: the enzyme that catalyzes the rate-determining step of fatty acid oxidation is carnitine acyltransferase I. Question: what is the negative regulator of carnitine acyltransferase I? Answer: the negative regulator of carnitine acyltransferase I is Malonyl-CoA. Question: what is the enzyme that catalyzes the rate-determining step of ketogenesis? Answer: the enzyme that catalyzes the rate-determining step of ketogenesis is HMG-CoA synthase. Question: what are the positive regulators of HMG-CoA synthase and ketogenesis? Answer: there is no positive regulators mentioned for HMG-CoA synthase and ketogenesis. Question: what are the negative regulators of HMG-CoA synthase and ketogenesis? Answer: there is no negative regulators mentioned for HMG-CoA synthase and ketogenesis. Question: what is the enzyme that catalyzes the rate-determining step of cholesterol synthesis? Answer: the enzyme that catalyzes the rate-determining step of cholesterol synthesis is HMG-CoA reductase. Question: what are the positive regulators of HMG-CoA reductase in cholesterol synthesis? Answer: the positive regulators of HMG-CoA reductase in cholesterol synthesis are insulin, thyroxine, and estrogen. Question: what are the negative regulators of HMG-CoA reductase in cholesterol synthesis? Answer: the negative regulators of HMG-CoA reductase in cholesterol synthesis are glucagon and cholesterol. Question: can you provide a brief overview of the urea cycle? Answer: the urea cycle is a metabolic pathway that converts ammonia, a toxic byproduct of protein metabolism, into urea, which is less toxic and can be excreted by the kidneys. The rate-determining enzyme of this process is carbamoyl phosphate synthetase I, which is regulated by the positive regulator N-acetylglutamate. Question: can you explain the role of insulin in the fatty acid synthesis? Answer: insulin promotes the synthesis of fatty acids by stimulating the activity of the enzyme acetyl-CoA carboxylase, which catalyzes the rate-determining step of fatty acid synthesis. Insulin acts as a positive regulator of ACC by increasing its activity, thereby promoting the conversion of acetyl-CoA to Malonyl-CoA. Question: what is the function of carnitine acyltransferase I in fatty acid oxidation? Answer: carnitine acyltransferase I is an enzyme that catalyzes the transfer of fatty acyl groups from CoA to carnitine, which allows fatty acids to be transported into the mitochondria for oxidation. It is the rate-determining enzyme in the process of fatty acid oxidation, and its activity is negatively regulated by Malonyl-CoA. Question: can you explain the process of ketogenesis? Answer: ketogenesis is the process by which fatty acids are broken down to produce ketone bodies, which can be used as an alternative energy source by the body during times of carbohydrate deprivation. The rate-determining enzyme of this process is HMG-CoA synthase, which converts acetyl-CoA to HMG-CoA. However, no regulators are mentioned for this enzyme in the context given. Question: what are the roles of insulin and glucagon in cholesterol synthesis? Answer: insulin promotes the synthesis of cholesterol by stimulating the activity of the enzyme HMG-CoA reductase, which catalyzes the rate-determining step of cholesterol synthesis. Insulin acts as a positive regulator of HMG-CoA reductase by increasing its activity, thereby promoting the conversion of HMG-CoA to mevalonate. On the other hand, glucagon acts as a negative regulator of HMG-CoA reductase by decreasing its activity, thereby reducing the synthesis of cholesterol. Question: can you explain the role of citrate in fatty acid synthesis? Answer: citrate is a positive regulator of acetyl-CoA carboxylase, the enzyme that catalyzes the rate-determining step of fatty acid synthesis. Citrate works by inhibiting the activity of an inhibitor protein called ACC inhibitor, which binds to and inactivates ACC in the presence of citrate. The ACC inhibitor protein is displaced, allowing ACC to be active and promote fatty acid synthesis. Question: can you explain the role of palmitoyl-CoA in fatty acid synthesis? Answer: palmitoyl-CoA is a negative regulator of acetyl-CoA carboxylase, the enzyme that catalyzes the rate-determining step of fatty acid synthesis. Palmitoyl-CoA works by inhibiting the activity of ACC directly. When the levels of palmitoyl-CoA are high, it binds to and inactivates ACC, reducing the rate of fatty acid synthesis. Question: can you explain the role of Malonyl-CoA in fatty acid oxidation? Answer: Malonyl-CoA is a negative regulator of carnitine acyltransferase I, the enzyme that catalyzes the rate-determining step of fatty acid oxidation. Malonyl-CoA works by inhibiting the activity of carnitine acyltransferase I directly. When the levels of Malonyl-CoA are high, it binds to and inactivates carnitine acyltransferase I, reducing the rate of fatty acid oxidation. Question: can you explain the role of HMG-CoA synthase and ketogenesis? Answer: HMG-CoA synthase is an enzyme that catalyzes the rate-determining step in the process of ketogenesis, which is the production of ketone bodies from fatty acids. HMG-CoA synthase converts acetyl-CoA to HMG-CoA, a precursor for ketone bodies. However, no regulators are mentioned for this enzyme in the context given. Question: can you explain the role of cholesterol in cholesterol synthesis? Answer: cholesterol acts as a negative regulator of HMG-CoA reductase, the enzyme that catalyzes the rate-determining step of cholesterol synthesis. When cholesterol levels in the body are high, it binds to and inactivates HMG-CoA reductase, thereby reducing the rate of cholesterol synthesis.
Thank you for watching our Q&A format video. We hope this helped you learn, review, and retain knowledge needed for the USMLEs. For more information on this topic, check out the link in the description. Now, if you want to take your USMLE prep to the next level, be sure to check out all our courses, which are structured to follow along with the First Aid for the USMLE Step 1 book. You can find us at USMLEQA.com. And if you're watching this on YouTube, be sure to like and subscribe.